Assalamualaikum and a very good day. Today we will be presenting our Task 3 network project for the course MTES3323 Discrete Mathematics. And also this project was prepared under the guidance of our lecturer, Dr. Muhammad Izwan. And here we will explain our network design and the concept involved. Alright, before we begin, let me introduce the member of our group. The first member is me, SYAHIRAH MAISARAH binti MOHD.ROSLI, and the second member is Muhammad IMRAN bin Rosli. And together we have collaborate to complete our network project for task 3. So now we will proceed with the next part of the presentation. For the introduction, network modeling helps us to understand and analyze complex systems by showing how different elements can connect and interact with each other. So in this study, we focus on the shortest path problem, which identify the most efficient route using this STRA algorithm. And also this project apply the algorithm to the real situation in our campus, IPG Campus Pendidikan Teknik, and showing that how mathematical concept can be used to solve practical navigation problem, especially in finding the fastest valid route from the mail block to the cafeteria. Next, moving on to our real world problem, Hakim, a student of IPG Campus Pendidikan Teknik, often travel to the cafeteria by car to have his lunch. However, to comply with campus rules, he must follow designed one-way pathway, even though taking shortcut against the flow would save time and fuel. This creates a dilemma where while going against the road could save time and reduce petrol consumption. It is essential to adhere to campus regulation. So the challenge here is to determine the shortest driving route from mail block to the cafeteria without violating these rules. Here, in this project, our main character is Hakim, a student who drives from the mail block to the cafeteria for his lunch. Although shortcut exists, but he must follow the official one-way route on campus. So the real challenge here is how can Hakim reach the cafeteria as quickly as possible without breaking traffic rules. So this problem is relevant because finding an efficient route can improve safety, punctuality, and reduce fuel usage. Moving on to the graph representation, to analyze the problem or Hakim's problem, we can represent the campus as a graph. So now we divide into three parts. The first one is vertices or class node. So each node represent a landmark in IPG KPT, such as we have mail block, TVET conjunction, laboratory block, library, and so on. The next one is edges or we call as connection. So the edge represent a road that connect with each other, connect two location with each other. And lastly, weight. So I represent all the distance in meter, and this allow us to visualize all the possible path from the starting point to the destination. Alright, for the diagram, so these are all the location that we included in our graph. So now we have M for mail block, A for mail block conjunction, B for TVET conjunction, P for lecturers block, L for laboratory block, H for library, T for three-way conjunction, G for agricultural workshop, S for surau conjunction, and C for the cafeteria. So next, in this slide, it is the combination between diagram and also distance. So this slide show the visual diagram of the campus layout along with all the distance between connected point. So all of these distance value will be used as the weight in our Distra algorithm. Alright, moving on to the assumption slide. To make our assumption consistent, so we made several assumptions. The first one is traffic regulation, where we strictly follow only one-way route, and the route that go against the traffic flow, such as we have AS and also PH, cannot be used. Next is road features. Elements like roundabouts and speed hump exist, but they are treated as a minor obstacles. Next is static environment. So here we assume the campus layout doesn't change during our analysis. Next, we also have constant speed, where here Hakim drive at constant speed to simplify our comparison. And last but not least, rule compliant. So even if shorter illegal route exists, but Hakim must also follow the official regulation. So these all the assumption help us to generate a realistic and a fair comparison of travel distance.
So for manual computation using Dijkstra algorithm, I will be talking about the concept and relevance of it before going into the steps. So for the concept, it is actually an effective way that helps find the shortest driving route. So in this scenario, we are trying to help Hakim go from meal block M in the red circle to the cafeteria C, the green circle. So its relevance is as an accurate assessment of valid travel routes that comply with traffic regulations, or in this case, one-way roads. Because as we can see, there are several weighted arrows, in this case M to A, and we cannot use the road A to S as it is a one-way road. So for the steps, I will be talking about some key points of Dijkstra algorithms in the tabular form. I will be using the corresponding colors of the sticky notes based on the color of the circle I use. So for the blue one, the starting point M or meal block is set to 0 as there are no traveling is needed to go there. So for next point, unvisited vertices are set to infinity, and once visited, they will be marked as visited by being highlighted and won't be reconsidered. Next, if there are several connected vertices, choose the shortest path while also evaluating all possible routes from the previous vertex. As we can see from B, there are P and G, which is two possible routes for Hakim to use. Next, update the distance from the previous vertex once a shorter traveling route is fine, as the green box that we highlighted from 1285 to 1240. And last one is retrace the steps to get the shortest distance as will be shown in the next slide. So in this case, I will be talking about the tabular method, how to retrace the steps. So basically, since we end our point at C. So looking at C values, 1323, if we see any other values that is higher than it, we will move horizontally. So in this case, infinity is bigger than 1323. That's why we move horizontally to the next checkpoint, which is basically 1240, which is S. So in this case, we'll repeat the same method until the starting point back. So since 1085 is bigger than 1240, we move horizontally to T. So we repeat until we reach M itself. So in this case, our sequence, our shortest path is basically M, A, B, P, L, H, T, S, C. So to verify our answer, we use software verification by using Notepad and Command Prompt. So basically, we establish the nodes, edges, and width values first into the Notepad app. Then we copy pasted it and save and renaming it to from txt file, text file to a Python script file, which is a code. And then when we execute the code, the Python script, we will get the results. And as we can see there, it is also said that the shortest path is MABPL where the total distance is 1323 meters. So how do we interpret these results into real life? So if we can see from a logical perspective, we can actually see that it is a way for us to validate which option is more efficient. So as we can see that MABPL HTSC actually has a distance of 1,323, while the alternative route, MABGSC, has the distance of 1,368. Despite the value only differ by 45 meters, it doesn't seem that big. It actually helps in practical benefits, as we can see in the second point. In general, it helps in minimizing traveling distances. It helps reduce vehicles' fuel consumption and also decrease the time taken to traverse around the campus. Specifically, as a future educators, to students and staff, it helps in foster punctuality and timeliness, and also reduce logistical uncertainties of campus transit. So, for the last point, interpretation, it helps in proactive and reactive maintenance. It helps alert campus management of pathways that require signage and maintenance priorities. For instance, let's say that a road has some some repairing that needs to be done. So campus management can alert students to use alternative routes in case that it happens. So also, they can provide a suboptimal diversion or alternative routes if maintenance ever occurs. So to conclude, I will be talking about why Dijkstra algorithm is practical and what is the recommendation for us to improve this method. So basically, in conclusion, Dijkstra algorithm actually has proven its practicality through empirical data driven strategy, as we can see from the calculation we did before, and also helps improve students' mobility while they're addressing the importance of time management and punctuality, and also closes the gap between theoretical concepts and its tangible benefits, proving that mathematics actually can be applied in solving everyday challenges, including mathematical computation, in this case, discrete mathematics. So, for recommendations, I would suggest that we evolve the algorithm decision making criteria by using multi-factor weighting system. It means that we doesn't only consider the distance, we also consider the walking speeds, we also consider delays, we also consider time, or maybe other factors like weather. So also consider another path conditions where we have staircases, road bumps, or unpredictable congestions. So these are the references that we use for this presentation. So that's all from us. Thank you so much.